All right, welcome everybody to week 7, day 2. Today we're going to be talking about the use of linear algebra in video game development, which seems to be sort of incongruous. Most people don't think of video games as requiring a lot of math, but people that have done video games know it requires a lot of math. The good news is the math looks maybe hard at first. In practice, though, is not. It's not actually that bad. Okay, so I'm gonna go over some stuff with you. We did dot product before, but I'll review that. So, in we'll do linear algebra for games. Okay, and for me, it's often a lot more fun to learn things like linear algebra if I have an application for it, right? So, like, I was talking to some students yesterday, and they were like, "Yeah, I like trig because like you can see the use of it, right? There's a flagpole, there's a shadow, and you can figure out how tall the flagpole is by looking at the shadow." And measuring the angle, which is probably 90 degrees. And for me, it's the same way. Like games actually is a ideal way of showing the use of linear algebra. Linear algebra is typically taught last in our math sequence. It's taught after derivatives and integrals and multiple integrals and partial derivatives and differential equations and vector calculus. Like at the very end of all that stuff, you get linear algebra. And so people think that linear algebra is really hard. It's actually not. And specifically, oh no, not more math. It's not. It's honestly not that bad. Okay. So there's kind of like 3 things you need to know. All right. So there's a point, and we'll be doing 2D, 3D, and we'll do 2D. It's a little less writing for me. If we were doing 3D, it would look like this, right? X, Y, Z. But I'm just going to do everything in 2D because it kind of just is less writing for me. So, for example, you've all taken algebra. If there's a point at 3 across and 5 up, we write it as 3 comma 5, right? You guys all cool with that? And you can even write it as like a vector if you want. A vector is a direction and magnitude. I commit evil with direction and magnitude. Okay, so a point can be considered a vector, or it's just maybe a point in space. Kind of depends. It makes no sense at all because differential equations are way more convoluted. I know, right? Like, to me, like linear algebra could be taught first. Like there's nothing in the class that actually requires calculus at all. It could just be algebra 1, algebra 2, algebra 3, which is linear algebra. Like you just do that in series. And linear algebra comes up all the time. Like calculus in computer science, like calculus will come up, differential equations will come up. How often they come up? 20% of all jobs in the field actually need calculus and differential equations. Somewhere around there. Not a whole lot. How many need algebra? Like all of them. How many linear algebra? 50%? I don't know. Like just spitballing numbers here, but it's actually really useful. Okay. And so you can have a point. You can also have a vector, which will look pretty much the same, because a point and a vector are kind of the same thing, right? And so, like, if you wanted to move this point 6 to the left, minus 6, 0, you just add them together, right? So if you want to add a point and a point, these are kind of the same thing, right? But we think of vectors as like an arrow. And we think of a point as just like a point in space. And mathematically speaking, they're kind of the same. So we can just add these two together, right? So we can add the point coordinate of 3, 5 to negative 6, 0, and we get negative 3, 5, right? So does that make sense? So if we are at 3, 5 and we add negative 6, we travel 6 to the west in the x direction. We go from 3 east to negative 3 west. Is that it's pretty straightforward, right? It's not too bad, right? It's addition, which all of you should be able to do. It's just there's 2 of them instead of 1 addition. So this is the x value, this is the y value. They get added up separately. Okay, that's it. And so this is a operation called translation. And translation just means moving. You might remember that from Unreal Engine, right? In Unreal Engine, I'll pull that up here and snap that to the top of the screen. I can click on Oh, this is the summer project. Oh, interesting. I can click on like this thing here, and then you can see I've got translate, right? And then I can move it. I can click and drag and move it in the Y direction, I can move it in the X direction, I can move it in the Z direction. Hit the arrow, right? Undo, undo, undo. So, yeah, so that's all translation is. And when I'm moving the camera around, I'm translating the camera, and I'm moving it forward in whatever direction I'm looking. So I've got a look vector, which is the direction I'm looking, and when I press W, it moves forward over time at a certain velocity. The velocity is set here, so by the camera speed thing. It's not 4 units; it's a scale of some sort. Okay. So yeah, you can add 2 points or vectors together, and you just move them that way. Adding 2 points together doesn't make sense. Like if you add your car's location and your location in the world, you're gonna get some number like off in La La Land, right? Like so if you've got the Velociraptor over here, right? So we're gonna make Dino Fan very happy. Here's my dinosaur. And so let's say the car is over here at like 1,000 and up by like 200. So it's like 1,000 units east and like 200 units north. It's like nowhere near the origin. And like I'm in my car, right? And I'm also at like 1,200 or something. If I add the 2 positions together, I'm going to get some spot like way over here. It's not useful for anything, right? But subtracting positions, that does make sense. That's something called a displacement vector, which we've talked about before. So if I were to subtract my location and the car's location, I get 0. I'm like, oh, I'm right on top of the car. I'm 0 distance away from the car. Cool. And so maybe you have code that says, hey, if you're within, a meter of the car, you can drive it or something like that. You know what I mean? And so we very, very commonly will subtract points. When we add things, we typically add a vector to a point to like move it or something like that. Okay. So we can add points and vectors. We can subtract 2 points to get a displacement vector. So, if we have a point here at 1, 2, 3, 4, 1, 2, 3. So if we have a point here at 4, 3, and we've got a point up here at 8, 4, 8. It's hard to talk and write at the same time. 4, 1, 2, 3, 4. It's not really to scale. So if we have a person here and we want to know how to get to here, this is our destination and this is our origin. Then what we do is we take the destination and subtract it from our origin, and that will tell us how far we have to move. In this case, 4 units north. So we would say 4, 8 minus 4, 3, and that says we have to move 0 units east or west, and we have, sorry, did I say 4? 5. And it's 5 units north. So this creates a vector pointing north that's 5 units long. Okay? So we don't travel any units east or west, we travel 5 units north. And that's how we can get from the origin to the destination. This is called a displacement vector. And we've done this in Unreal Engine already. Okay. And with the displacement vector, there's 2 things you can get. You can get the distance, and you can get the direction. You get the distance by doing vector length, and you can get the direction by doing normalize vector. Okay. And so if we normalize the vector, we just get a little, unit, 1 unit long, pointing north, like that. So it's a little arrow pointing northwards. That's like the direction we need to travel. And typically, we always express directions in terms of unit vectors. In other words, a vector with a length of 1. And so it's just pointing north, 1 unit. And if we want to know the distance, then we take the vector length, which is the Pythagorean theorem, and that will give us an answer of 5, right? Because it's 5 units north. So you take the Pythagorean theorem of a squared plus b squared, square root it, you get 5. Okay. And so that's Pythagoras there. That's basically you take the vector and divide by Pythagoras. So in order to normalize the vector, you take the vector and you divide it by the length of the vector, and that gives you the normalized. That gives you that. So 0, 5 divided by 5 is 0, 1. Okay. Makes sense? So we have a pointing north, 0, 1. And so we've got the vector 0, 5. We divide it by 5, and we get 0 and 1. That's the length of the vector. It's this number here. Okay. And so you can get direction, you get distance, and these are the fundamental tools that you need to make games, right? What direction should I be looking in? Like if I want to be walking from here to here, let's say that you have just some AI that's just like pathing around, and it's like, oh, I'm currently at 4,3, I need to move to 4,8. You do the displacement vector, you figure out the direction that your target is, and then you rotate the character to look at it. So that's it. And now the character is walking in the direction he's looking, and everything looks fine. These are like your basic fundamental tools of video game development from linear algebra. Now, in addition to points, there is something called a matrix. So before we get to matrices, though, I've talked about dot product. I haven't talked about cross product. So let me do that one first. So let me just finish off vectors a little bit. So let's say that you've got a vector like this, and you got a vector like this, and you want to know, are they pointed the same way? This comes up a lot for things like backstabbing, right? Right, you hit somebody, you want to know if you're behind them. And so you're behind them when you're both looking in the same direction. If I shoot in front of me and I hit somebody and he's looking the same direction that I am, it's a backstab. But you're very rarely going to be pointed in exactly the same direction, right? Because I could be a little bit off, they could be a little bit this way. And so there's going to be some theta, some angle between you and them. And what you want to do is you want to say, like, if I'm within 30 degrees of being straight behind them, it's going to do double damage or something like that. And you compute this thing by doing something called the dot product. So you take the you take two normalized vectors, vector 1 and vector 2, and you dot product them with each other. And that will give you a number from -1 to +1. So these have to be normalized, which means they are length 1. And if you dot product two normalized vectors with each other, we've done this before a couple weeks ago, it'll tell you, are they pointed the same way, right angle, backwards, somewhere in between, things like that. So the cheat sheet is this. If vector 1 and vector 2 are pointed the same way, you get a 1. If they're pointed kind of the same way, you get like a, 0.8. If they're pointed at right angles to each other, you get a 0. If they're pointed like kind of a little bit in opposite directions, you get like a negative, 0.2 or something like that. If they're mostly in opposite directions, you get like a negative 0.7. And if they're in completely opposite directions, you get a -1. Okay. And so it's equal to the cosine of theta is what this is computing. And so what you do in Unreal Engine is you just feed one of the vectors, the forward vector of one person, the forward vector of the other person, you feed it into dot product, and you get a number from -1 to +1. And that tells you you're looking the same way, looking at right angles, looking at each other. And a lot of times, yeah, you want code that's like when you're looking at each other. Like if you want to interact with an NPC, when you hit use, maybe they ignore you if they're facing away from you. So if you want to make the person have to walk in front of an NPC, then you take their forward vector and your forward vector, you dot product them and make sure that they're negative at least, or maybe less than -0.4 or something. You just kind of eyeball it. And then you can have code that only works if you're looking at somebody and they're looking at you, or a vending machine. You only want to be able to use the vending machine from the front, not from the back. So if the vending machine's pointed forward and you're pointing forward and you hit use and you hit the vending machine, that means you're behind it. And it's really weird if you hit use and then a can of soda pops out when you're punching the cardboard back of the vending machine. So what kind of math is taught in CSI 26? Discrete math. We don't do this in 26. This is linear algebra. this math is not something the Jedi would teach you. This is very specifically linear algebra for games. But to me, it makes linear algebra a lot more fun. Okay. And so the equation for dot product is just equal to x1, y1 plus x2, y2. Very easy to compute. You don't even have to do trig. You just multiply the x component of one with the x component of the other, and the y component of one with the y component of the other, and then that'll give you a number from -1 to +1. If they're normalized, they have to be 1 unit in length. If they're not normalized, then the result will be scaled by the size of the vectors, which sometimes you want, usually you don't want. At least not in the applications that I have. Okay, so we've talked about this before, so I'm just going to move on. I'm now going to talk about cross product. So cross product is one person to the left or right of another. So if a person is here and they're like looking this way, this is their forward vector, and there's another person over here, this person is to the right. And then this person over here is to the left. Yeah, I mean, if you want to, I can send you the video lectures for Site 26. I recorded an entire season of them last year. Or if you want to come to 26, it's 9 a.m. on Tuesday, Thursdays. Or you just watch the videos. So, cross product is to tell if somebody is to the left or if somebody is to the right of something, usually. There's other uses for it as well. Cross product's pretty cool. And so if we take a displacement vector, like we got this person here, we got this person here, and we have this displacement vector here. And so we'll call the forward vector here v1. We'll call this displacement vector v2. You compute v1 x v2. This is cross product. It's a different symbol than the dot product. The dot product, we draw a dot like this. Or if you want, you can make it a hollow dot to indicate dot product, and x indicates cross product. These are two different kinds of multiplication. And so in normal math, x and dot mean the same thing. They're just both multiplication. In linear algebra, there's inner product and outer product, and one is represented with a dot, hence dot product. The other one is represented with an x, hence cross product. So they're slightly different. Okay, so dot product will, if it returns, so if you have, just as a cheat sheet, if they're pointed the same way, you get 0. If they're pointed in opposite directions, you get 0. If the person is to the left, here's v1. If the person is to the left, you get a negative number. This would be like negative, I don't know, 0.8 or something. If the person is to the right, you get like, sorry. If they're to the left, you get a positive number. If they're to the right, you get a negative number. So this area over here is positive. The area over here is negative. And the more negative it gets out to a right angle. So a fully right angle to the left is equal to 1. And a fully right angle to the right is equal to -1. Okay. And so this is very useful if you want, like, you're driving down the street and there's an AI in front of you and they want to jump out of the way. You know, they should jump away from the car instead of like into the car. Okay. And this is computed by doing, what is it, x1, y2 minus x2, y1. And this is called the scalar cross product because it gives you a number. Okay. So if you pass in, if you cross product 0 and 1, and 1 and 0, so 0, 1 is pointing straight up, 1, 0 is pointing to the right, you're going to get 0 times 0 minus 1 times 1, you get -1. So if this is vector 1 and this is vector 2, you get -1 as the result, because vector 2 is to the right. It's clockwise from vector 1. Okay. And then that's funny. And then the other alternative would be like, vector 2 pointed this way, which would be -1, in which case you're going to get -1, which is +1. And so if the vector is pointed this way, you'd get a +1. Okay. So cross product is very useful for telling you things are to the right, things are to the left. We use this, for example, in computational geometry. So like imagine you've got a polygon that looks like this. Not quite a polygon. Let me, no, too much. Okay. Like that. Okay, so let's say we've got a polygon of some sort. It's a convex, something called a convex hull, okay, which is a convex polygon. And you want to know if a point is inside of it. Is this inside of the polygon or not? It's actually pretty common actually in games. Like, is something within a boundary? Comes up, right? Are you in the lava field? Are you inside of a box? Are you, if you're drawing something to the screen, you want to only draw the pixels that are inside of the polygon. So, so what you do is you check to see if this point is to the right of everybody. Okay. So there's actually different ways of doing this. There's more optimal algorithms, but like, let's try this again with thing held straight. Okay. So if this is vector 1 and this is vector 2, then if this is a negative number, it's to the right. And then you do the same thing for this one. And if you get a negative number, it's to the right. You do the same one for this one. If you get a negative number, it's to the right. And you do the same one between this vector 1 and this vector 2. If you get a negative number, it's to the right. You do the same for this vector 1 and this vector 2. If you get a negative number, it's to the right. And if it's to the right of everybody, and you have to have this thing laid out clockwise, right? Sometimes people draw convex hulls counterclockwise, in which case everything has to be to the left, right? Do you guys see that? Like if it's to the right of all of the edges, like all the sides of the polygon, if it's to the right of all of them, then it's within the polygon. Do you guys see that? So it's basically 5 cross products. So like if we had a point over here, like it would be to the right of this one, but it would be to the left of this one, right? So that'd be a positive number. If you get any positive numbers, it's outside. Questions? Does that make sense? You want to write that in code? Too much math? Oh, we have not even yet begun to fight. Okay. The nice thing is, like, you just put this into a function. You say, hey, tell me if this point is to the right of a vector, and it returns true or false. You just do that for each of the 5 edges. If it's true for all of them, it's within the polygon. If then. Yeah, or you add together all the results and yeah, that kind of stuff. Okay, so dot product enjoyers, yeah. So that's cross product. Cross product also has something, not just scalar cross product, it's got something called vector cross product. And so vector cross product is related to scalar cross product, but it creates a vector instead of a number. So all of these things here are just returning a number from -1 to +1. -1 means it's to the right, +1 means it's to the left, 0 means it's either ahead of us or behind us. Okay? Vector cross product actually returns a vector. So if you have a arrow here and an arrow here, then it's going to return a vector using the right-hand rule. So you put your 2 fingers on the 2 vectors, and then it creates a third vector sticking up out of the screen. If it's a right-handed coordinate system, which, not all of them are. There's remarkably little consistency over if coordinate systems should be right-handed or left-handed. if X is forward, if Y is forward, if Z is up, or Z is into the screen. It's a mess. And I actually just posted a graphic on the Discord channel showing all the different standards used by different people. I used to work in a system where we were using 2 different coordinate systems at the same time, and that was just not fun. It was really not fun to have to switch back and forth between a right-handed and a left-handed coordinate system in the same game engine. Like, so many times I'm trying to walk forward and my guy is just sliding to the right. I'm just like, why? Why is this my life? So what is vector cross product used for? Well, imagine you've got a triangle, okay, and it's out in 3D space somewhere. So you've got a triangle that looks something like this, and it's just kind of just out there. It's rotated somewhere in space, and you want to know. So you feel with your strafing, yeah, it's. Or you're trying to slide down a mountain and you're sliding sideways, and then you go off a cliff, and instead of falling down the cliff, you slide along the cliff. Like, it was just like so much pain. It was just ridiculous to deal with. Okay, so let's say you've got a triangle. It's just out there in space somewhere. It's rotated in some direction. You see how my hand like is more lit when it's facing the light up here, and then like when I kind of tilt it, I'm getting some light off the monitors. But like, do you guys see that? It's like if my hand is pointed up towards the light, which is that way, this is maximally lit. You guys see that? Is that coming through on the video? Okay. So as my hand turns away from the light, it gets less and less lit. And so this is called the normal vector, right? Which is different from a normalized vector. A normalized vector means it's length 1. A normal vector is the direction coming out of a surface. It's a vector perpendicular to the surface. So no matter how I move my hand, the normal vector is the black pen, okay? So if you want to know what the normal vector is, well, that's useful because that tells you how much lighting you're going to get. So we got our triangle here, we got some light bulb over here, and it's radiating light in all directions. Let's not have it cover up the vector cross product. So we got a light bulb here. And it's shooting out light in all directions. And then we've got this triangle here. So how much light should the triangle receive, right? Because if it's like dead on, like you see how you can't see my hand now? It's completely invisible, right? If it was a triangle, it'd have a size of 0 from the side, right? So if the light was right there, this would be fully lit, and then this would get less and less lit, and then this would get no lighting at all because the light would all be passing just right past it. So what we need to do is compute 2 things. First of all, we need to do the cross product. So we cross product vector 1 and vector 2, and that will give you the normal vector. So that is the normal vector here, okay? And so if you cross product two basis vectors of a triangle, it will give you the third, right? And that's the normal vector. Okay, it doesn't give you the third edge of the triangle. You can actually cross product any 2 edges of the triangle and get the normal vector out of it this way. Doesn't matter which 2 you pick. Any of them will give you the normal vector, and you normalize it down to size 1. And then you've got this guy's location here. We've got our location here. You do a displacement vector. You just displacement vector from the triangle to the light bulb, and then you normalize it down. And you'll end up with something like this. Like, this is the direction to the light. That's vector 1. We have our normal vector, which I'm going to normalize down as well. You see how they're kind of like pointed in the same direction here. That's vector 2. And you dot product them. So you're going to do a cross product to get the normal vector, and then you cross product the direction to the light with the normal vector, and this will tell you what percentage of the light you're going to get, not counting for like attenuation from distance, right? So if the normal vector is pointed right at the light, you get 100% light, and if it's pointed at 90 degrees, you get none of the light. And so this is like how you do lighting. So the dot product of the normal vector and the displacement vector is how much light you receive. And all these things are just like, these are just like tools, and you're going to use them. You're going to use them a lot in game development. Not to scare you off. I waited until after the drop deadline, right? No, wait. You still drop? Maybe I should stop talking until after the drop deadline. Then we'll do more math. Okay. Yeah. Probably that is actually enough for you. I think with matrices, we'll pick that up later. But matrices allow you to do things like rotate and translate as well, and scale, and skew, and some other stuff. So we'll pick up matrices at a different time. I think that's pretty good. So let's do this in Unreal Engine, okay? And so I'm going to go ahead and close this out, I guess. Go to Unreal Engine, and I'll show you guys some uses for this stuff. And so none of the algebraic equations are like that bad, right? It's like 2 multiplies and an add and a subtract for dot product and scalar cross product. And, you know, it's just mostly a matter of like, you just don't know how things work, you know? And, you know, once you kind of understand how things work, you know, everything kind of starts making sense, or at least it should. So let me show you this. Let me pull a cube up here. Drop this underneath the sea. Under the sea. Done, it's better downwards, what to take it from me. Okay, so we have no lighting under here, right? We're underneath that solid water surface. We're getting no light. It is black. Okay. So if I were to put a light under here, and I'll just do a normal flashlight, or normal light bulb. Notice how the normal of this surface here is pointing towards the light, right? You guys see that? So we go into wireframe. You can see that each one of these triangles here, its normal vector is pointing outwards. It's pointing towards the light. And pointing directly towards the light. So you can see that the front of this is completely lit, right? It's getting all of the light from the light bulb. The only fall off is due to the light bulb. Like if I move the light bulb far enough away, there's attenuation, just because the light intensity decreases inversely proportional to the distance to the surface. Because you know, the further away you are from a light bulb, the light is traveling in an ever-increasing radius, and the same amount of photons are having to cover a smaller and smaller, you know, like there are fewer and fewer photons hitting the same target the further you are away, because it's going out, it's spreading out further and further. So if you move a light bulb really close to it, it's very bright, and then if you move it far away, it attenuates down. Okay. But also notice that the sides of it are completely black. The back of it is completely black. And the side here is actually picking up a little bit of bounce lighting, because the light bulb here is actually hitting the terrain, and the terrain is reflecting light because we got ray tracing on. This is not what you would see if ray tracing was off. If ray tracing was off, this would just be pitch black. But as it is, we're picking up a little bit of bounce lighting because we've got something called Lumen in UE5, and it does all this really cool, really neat stuff for us automatically. And so you can see that if I move it further away, it's black, but if I get it really close to the train here, there's actually some bounce lighting coming up and hitting the cube there. And there's probably a little bit here, maybe not. Okay. Then if I move it to the side, you can see that the front is now less lit than before, right? Because the amount of light it's getting is equal to the dot product of the normal vector and the direction to the light bulb. If they're exactly the same way, it's 100% lit. And as the light bulb kind of starts moving off to the side, the dot product starts returning a number closer and closer to 0. And once this thing is completely off to the side, it turns into 0, and you get no light. If you have just 10% of the light, it's still pretty good. Once it hits 0, then it becomes black. Okay. And so that should be right. Yep, look at that. Right down the side. Right when it hits 0, boom, black. And now this side is lit. So do you guys kind of understand lighting now? Maybe a little bit better? What do you think? pause it, realize it on my coffee with me. Be right back. So ray tracing just makes everything more complicated, but also looks better. And so instead of just the surface being directly lit by a light, now you've got to handle, the fact that the light can hit here and bounce around and bounce around and bounce around. And it's actually quite a challenge to solve. Pilot active. Oh, interesting. Okay. So that should kind of show you guys how lighting works, right? See, the areas that are kind of off to the side are kind of gray. Things that are more facing it are more white. So the top's a little more gray than others. Okay, anyway. So we haven't done a post-processing volume yet, have we? Have we done post-processing volumes and physics volumes and things like that in this class? So the fall class is always dicey because I teach the summer school class, and then right when summer school gets out, I start teaching the fall class. It's like, I feel like I've taught this recently. So have I gone over post-processing volumes and physics volumes and things like that? Yeah, okay. So we'll have that be our homework, okay? So we're going to make an underwater wonderland, okay? So maybe actually put in some crates and things like that kind of floating around. Maybe we can even get into the water system. See how much time we have. Okay, so we'll start off by showing you guys a couple more volumes. You're right, I did talk about volumes when I talk about like this. Like we have the nav mesh volume. There's a lot of volumes that you can like invisibly place in the world to do things. And so, for example, if I wanted to add a invisible wall, like this is very common in video games, right? Have you guys all like tried walking off the edge of the map and suddenly you're just like, and you're like your face is smashed up against an invisible wall, or like the bushes in Pokemon. You just for some reason, like you've got a dragon, but like there's a bush. Like I don't know what to do here, man. Helpless before it. So there's something called a blocking volume. And so if you drag out a blocking volume, by default, all the volumes are going to be 1 meter cubed in size. And you can see it's actually blocking the nav mesh. That's because nothing can move through a blocking volume. And if I make it a little bit wider this way, I don't know if you guys can see it, but you see how there's like this like little orange box here? That's the blocking volume. And I can make it as tall or as short as I want. I'm just going to put it like here. And so it's just going to not show up at all. Look, I've got no visible indication there. I'm running around, I'm doing stuff, and then I'm like, let me go for a swim in that lake. You walk up there and bloop, nothing. Right? You guys have all seen this in video games, right? Where they just like will stack an invisible wall, and you're like, what? Like I was playing Tiny Tina's Wonderlands the other day, and like I'd found like a back way up to getting to one of the golden D20s you're trying to find by like jumping up the backside of the train, and then my face went like this because they just placed an invisible wall there, and I couldn't climb. Like it was a jump that I could make, like it was just a little stair step that I could go up, and they just thrown a blocking volume up. And I was just like, oh, come on, man. Like, the whole point of these things is to find clever ways of, like, getting to it, and you're blocking me here. Like, come on. So, right. So, yeah. So blocking volumes are very useful. Here, it would be super annoying to have one. So I'm going to delete it. And it's trying to load your animated GIF, I think. Yeah. But like if you put it off on like the horizon, you can use blocking volumes to trap people into your world. There we go. Right, so you're running and bloop, and then you just bounce off of it. Okay. So, so what other kind of volumes are there? Well, there are, today we're going to really focus on two of them. We're going to focus on a post-processing volume, and we're going to focus on a physics volume. So physics volume allows you to define areas of your map that have different physics. And so you can have like different gravity and things like that. So a big use of a physics volume is to have water. Okay, so if I drag it out, you'll see here I've got this invisible volume, and I'm just going to make it big enough so that it kind of like goes up to the around there. It looks probably pretty good, maybe a little bit taller, I don't know. There, and I'm just going to have it cover this underwater lake area. Okay, just scale it out a little bit and just have this. Oh, I just clicked on my face. I'm just going to have it cover. If you can dip out of the level too and just kind of make sure that everything's covered. Yeah, okay, that looks pretty good. All right. So this physics volume here is going to represent the area where we can swim. Okay. And by default, we can't swim because the surface of the water is solid, and we're going to have to fix that in a second. But with this physics volume selected here, and details tab, and you can scroll down here, and you can say this is a water volume. And if you turn that on, that makes your character swim automatically. Okay, so your character, and we can look at the swimming properties on your character, which usually need to be tweaked because it's the default swimming is pretty bad. But all you have to do is basically drag out a physics volume, say it's water, and then just kind of like everything kind of works naturally. So you don't have to do too much more than that. Yeah, basically. Okay, so if we try walking over to the lake though and jumping in, you will see that the lake. Oh no, I guess I did turn the lake off being solid. That's cool. All right, so if your lake is solid though, what you need to do, yeah, let's do this again. And if I jump in, then you notice that I'm kind of like sliding around. You see that? Like this is the default swim behavior. I can't jump anymore. I'm just kind of floating and kind of running in space. Like it's kind of garbage, right? But you can see like when I'm on the ground, I can jump, but otherwise I'm just kind of like moonwalking everywhere. Like I said, the default swim physics is not good. Cursed, yeah, it's the kind of thing you have to mess with. Okay, but that's all it took. Like all I had to do was drag out a physics volume here, boom, have it cover the whole lake area, and just turn on water volume, and there you go. Okay. Another thing we probably want to do is we want to have lights underneath there, right? So I actually, you can see this whole underwater area is dark because the surface of the lake is blocking all of the sunlight. So we're actually probably going to need to make a couple different lights underneath there, just to kind of light it a little bit. Just gonna make a few underneath here. There you go. And now it's not going to be like pitch black, right? Which it was before. Come underneath here. You can see it's now, it's fine, I guess. It's a little too bright, I think, but whatever. We're going to fix that in post. So these zombies are still running around. Bruh. Bruh. Die, zombie. Die. Bruh. Okay. So what we're going to do is we're, now that we've got a physics volume here, which again is kind of like, we're going to now add a new volume, which is called a post-process volume. And a post-process volume allows you to do all sorts of cool tricks with camera effects and things like that. So if you've ever heard people use the phrase, we'll fix it in post, that comes from the movie industry, right? Where you do a take and maybe you do a bunch of takes and like maybe none of them are perfect. And so the director will say, we'll fix it in post. And so basically after you've done production, then it goes to the video editors and things like that, and they can clean up a lot of things actually. And so there's a whole industry of people who will do things like redub audio. So like maybe one take had better audio, and so they'll redub, you know, your words from one take onto your mouth on another take, or they'll clean up the sounds of, like, you know, if I'm hitting the table here, this comes through as like a really cursed popping sound. I'll turn the sensitivity down a little bit on YouTube. So there's a lot of things that you can actually do, like if there's weird crinkling effects and things like that, you can take them out or add them in. Like if somebody's eating like a Snicker bar, usually that's so quiet it doesn't actually make any sound, right? And so what they'll do is they'll have a Foley engineer come in and like add the sound of, like, you know, let's say I need to get like a plastic bag, you know, make that sound of like opening something. So in Unreal Engine, post-processing is mainly used for camera effects. And so again, I'm going to scale it up. You know, I'm just going to actually copy the physics volume here. So physics volume, what's the size? 11 meters by 13 meters by 3 meters. Okay, so I'm just going to scale you up to 11 meters by 13 meters by 2 meters. Oh, it's locked. Scale, sorry. 13 by 13 by 3. And did I not select it? Okay, sorry. Post-processing volume. Okay, there we go. All right, let's try this again. 13 by 11 by 2. And I'm just going to pop out of the world and just, again, make sure that the volume is kind of encompassing that whole underground area here. Looks pretty good. It's underneath the surface. Okay. A little bit bigger than it needs to be, but it doesn't matter unless I'm going to have people running around over here, which is underneath the world. It should be fine. Okay. So basically, you drag out a post-process volume and you scale it up rather than scaling it by hand. Again, I just looked at the physics volume scale and just set it to be like 13 meters by 11 meters by 2 meters. Easy peasy. And now you can go through all of these cool little options here, and all of them are off by default. So by default, if I jump into this region that is a post-processing volume, you'll see absolutely nothing, right? Because by default, everything's off. So what can you do though? And what's cool is that you actually don't need to run the game. The preview here will actually show you the effects of the post-processing volume. So if we turn on high quality Gaussian blur and near transition, let's see if we can get some stuff going on here. Is it not allowing me to? Oh, it's mobile. Never mind. We're not on mobile. Okay. Check all those. Bloom method, standard, intensity, threshold. Drag the intensity of bloom up. Okay. So if you've ever seen bloom on video games, it adds halos around light effects, kind of simulating like the atmospheric. There's like moisture in the air that will like scatter light, and so like have you ever seen like a street light at night and there's like a halo around it, kind of, or maybe you have like cataracts. Either way, you know, and you see like a halo around a light. So you can turn bloom on, and some video games turn bloom like way too high. Like you can see that like when I'm glowing there, you see how there's like a halo around me. Like a Beyonce song or something. Yeah. See that? It's like really bright, you know, and it has that effect of like, psh, you know, in your eyes. Yeah, do you guys see that? Okay. So that's bloom. You can turn bloom on. You can drag it all the way up if you want to have like the experience of playing Oblivion all over again. That mega bloom turned on by default. You see how that thing's just like glowing now, and it looks like your eyes are like kind of blurry a little bit. Yeah, so that's bloom. It also creates that weird shimmering effect, which I don't really like. So if you turn that off, Actually, the shimmering is just from the grass. But when you turn bloom on the sun, like the sun goes like this, which looks really distracting. I'm going to turn the bloom way down, but I'm going to leave it on. It looks kind of nice, I guess. Adds a little bit of fun. Convolution bloom. I don't know what that does. Okay. Exposure. Let's see here. Chromatic aberration. This is kind of fun. So chromatic aberration represents like when you're looking through a lens. Like if you've ever played a game with like a sniper rifle, like any of the like Sniper Elite series or things like that, they typically will add in chromatic aberration. It's the kind of thing I turn off actually on most video games because it's kind of annoying. So you can actually see that like the edge of the cube here is no longer like one color, right? So you can see that there's a red line and there's a yellow line. And so what chromatic aberration does is it actually represents the physical reality of light passing through a prism. High intensity light refracts stronger than low intensity light. And so that's why if you pass white light through a prism, the purple light bends quicker, and then the longer spectrum light, the lower frequency light like red, bends less strongly. And you'll get these things on like anytime you look through a binocular or a sniper rifle or something like that, there will be a little bit of chromatic aberration. You can see down here, everything's like blurry looking because the intensity is like way too high. You can see like it's actually pulling the different channels of light apart from each other. And I don't like it. But like a lot of video games are like, oh, it's so realistic. And I'm just like, no, you're just blurring like I don't need that kind of realism in my life. You know what I mean? Like this just bugs me, you know? And so if it's really, really subtle, like maybe I can get away with it, but I'm not like a huge I'm not a huge chromatic aberration fan. Ooh, that's cool. I like that. Huh. Wild. Yeah, so all these things I want you guys to just play with. So you're gonna make an underseas area. You're gonna do under the sea with Little Mermaid. And basically you're going to create an aquatic environment that kind of looks cool. So you're going to have a physics volume and you're going to have a post-process volume that kind of makes it cool. I don't like this. That maybe you can see there's a little bit of a blur, like a little bit of a separation there. Dirt mask. You can add dirt to the camera. There's no texture here, so let's pick something. So you can add dirt. Normally this texture would be like splotches and things like that. So like when you're during a bike race and somebody kicks mud on you, then usually the camera has like some, speckles of mud or something like that on the screen. Normally you wouldn't use a checkerboard pattern like this, but it kind of demonstrates the thing. What video was it that showed how to lower the kill floor? I can just show you now if you like. You go over to world settings, which is right here. It was right there. Let's see, nothing selected. Okay, window world settings. There we are, and then kill Z. So you want to, by default, the kill plane is set like right below the ground. And if you don't set the kill plane like down a ways, you're gonna die instantly when you like try and go into the lake. So, yeah, I set it to negative 100 meters, which should be fine. And if I die before I wake, pray the Lord my soul to take. Hush, little baby, don't say a word. Okay, I don't need you. Okay, so post process volume. Here we go. All right. So yeah, you can add a dirt mask to have dirt on the camera. That's kind of cool. Change the colors on it. Camera settings, shutter speed, ISO. Sure. Local exposure. basically just click on these things and just, oh, a lens flare, like if you want to be a J.J. Abrams. There you go. Look at that. Yeah. My face out of the way. So you get a lens flare, right? Yeah, there's the shimmering I was talking about. When you have bloom, um, you oftentimes get these like weird shimmering effects I don't really like very much. Yeah, so if we go around here, you can probably get some. Yeah, there you get lens flare effects. Kind of cool. Image effects. Oh yeah, vignette. It's kind of cool. So I actually recommend you use vignette for your underwater area. It's too bright right now, so let's pull it in a little bit. Okay, so what vignette is? It's a term from photography when you want to like emphasize somebody's face in a portrait. So if you vignette somebody, then what you do is you darken the corners of the image. And so, for example, you see how it's vignetted here. Vignette techniques. You see the corners are darker. And so what that allows you to do is emphasize the center of the screen. It's also really useful for making it look like you're underwater because it kind of has the effect of like darkening the corners of the screen. So wherever you're looking, you can kind of like see the things, but then like the corners are kind of darker, and it actually do you see that? Like, okay, the lens flare's got to go. The lens flare does not belong underwater. Off. Okay. But it gives that effect of being underwater. So if I turn that off, you can see everything's bright and sunny if you vignette it. And I've actually written games before, so like as you start running out of oxygen, the corners of your eye, the camera, start darkening. And so it kind of simulates like running out of oxygen, because when you start running out of oxygen in real life, you get tunnel vision. And so you can still see the center part of what you're looking at, but the edges of your eyes start going black in real life. And so like if you have an oxygen meter, what you can do is you can turn up the vignette as they're like suffocating, right? So now I've got vignette turned up to 5, and you can see just barely in front of you, right? So basically that's what I do. So I'd start off, it's like that, and then underwater would probably be like that. And then as you're suffocating, it would go darker and darker like that. So you'd still play the game, right? But like you could see the walls are closing in. It's also a great visual reminder. You're suffocating. You need to get to the surface before you die. Okay, so that's a really useful thing for simulating underwater areas. Depth of field. Let's see here. So we can get something to happen here. There we go. So you have 10 centimeters, 20 centimeters, half a meter. Those artifacts. So you can have like blur depth, radius. You have things like in front of you. Let's see if I forget where it is in focus. So yeah, that's all sorts of fun in a video game, right? So you can have some areas that are like in focus, and then the other areas that are out of focus. This is a very common trick in filmmaking to have the viewer's attention focused on a certain spot. So it doesn't really work that well in video games, because in a video game, like I might be looking here, but I might be looking, oh look, there's a monster over there or something. And if you make it blurred, people get upset at you, right? So basically, I don't really like depth of field very much. In a cinematic, maybe. And so you can use depth of field to like highlight something. So like if you've got like 50 people in a crowd and you set the depth of field so that one person's face is in focus and everybody else is out of focus, the human eye, your brain will automatically be drawn to the person that's in focus. Why? Because when the human eye looks at something, it focuses on it. And so it's a very subtle way uh, of saying this is who the camera is paying attention to, so you should pay attention to it also. And so you can lead people's attention to certain spots inside of a movie by focusing on them. And if you use a narrow area that's in focus, then people will know, oh, I'm supposed to be looking at that book right there. That book's special. It's got a skull on it. I wonder what that's about. Whereas if you just had everything in the world, like they don't know what to look at. And it doesn't really work that well in video games, but you could probably play with this to make the underwater area kind of blurry as well. Color rating, temperature type. So all lights have a temperature. So there's no such thing as like white light, so to speak. If you've ever seen lighting at like a store, if you've ever bought light bulbs, there's so-called soft white light bulb. And so a soft white light bulb is more yellowish, right? And then they've got multicolored LEDs. But, yeah, here's a good. So they've got different colors of white, which seems really weird to us, right? Because like white's white. White's just all the spectrums of the color. Yeah, but it I don't know if you guys know this, but the color of the sun, like daylight outdoors, changes constantly. Like when I did filmmaking, like it's a constant issue because the color of the sun changes, and if you don't adjust for the white balance, like this is called white balance adjustment, right? Where you kind of figure out what color of light is hitting you, and you subtract that color out so that it just looks neutral. If you've ever taken try to take a photograph of like a sunset, what happens is the automatic white balance calibration subtracts out the nice warm glows of the sunset, and you get something that doesn't look very colorful at all, right? Like you're looking at the sunset, and you're like, oh, it's so beautiful. Let me take a picture, and then it just turns out as garbage. You guys know what I'm talking about? Have you guys done that before? Like try to photograph a sunset? Are you guys still here? Yeah. So usually when people light their homes, they use it with a soft white because it's kind of like reminiscent of like a fireplace or something like that. It's kind of warm and comforting and cozy and things like that. If you really want, you can use a warm white. I actually have dimmable LEDs so that as I dim them, it actually changes from like neutral to soft to warm white. So I can actually adjust the color temperature in my rooms. And so like if I'm like relaxing at the end of the day, a lot of times I'll turn it all the way down to warm white and just have it kind of dim and warm. And it just kind of feels like, you're just around a campfire with your friends and the fire is burning and kind of dying down a little bit. It's a very soothing kind of experience. You have a lamp like that? Nice. Cool white, though, is more like sterile, like a doctor's office, an operating room. You would think of as being in cool white. And these are the kinds of things you have to think about when you're making a game, by the way. Like you need to think about the color temperature of your lights because they tell us something subconsciously. Okay. And so in your post-processing volume here, you can adjust the color temperature of the area. So if we're here and we adjust the color temperature to be bluish, look, it looks like we're kind of underwater now. Look, you see that? So it's kind of like there's kind of a bluish tint to everything now. If I come up out, normal suns, underwater, it's bluish. What do you guys think? Kind of cool? You like it? Yeah, I like it too. Then you just add colors to it. For me, the color temperature is like a little more natural because it kind of like it just kind of plays with the whites in the white color in the area without making it too dramatic. But if you want, you can just add like you just add like colors and stuff like that to it, right? So you can just like play directly with the colors underwater here. Shadows, you can play with all those, midtones, mist film. Yeah, there's a film effect. And so these are all like the different ways you can play with the lighting curves and things like that, and make more or less dramatic things. Should be lumen by default. Increase the quality of the lighting. That's cool. So you can control like the ray tracing settings and stuff like that. I didn't know you could do that. It's cool. So you can make really, really accurate ray tracing. That's pretty cool. I didn't know you could do that. Indirect lighting. If that's doing anything, I don't think it's doing that. So you can control all these different kinds of things. Motion blur. Okay, that's cool. I hate motion blur, by the way. Does anyone here hate motion blur also? It's one of the things I always turn off whenever I'm playing a new game. I always disable motion blur. Film grain is pretty cool. This is actually great for like underwater areas too. So if you like, I don't know if it's coming through on the video, like it adds like some random pixels to the thing, so they're like flickering. And so again, this can like simulate like when your eyes start running out of oxygen, they start flickering like that. And so you can simulate like lack of oxygen and things like that in very subtle ways that don't really like hit people in the face. Like, warning, you're running out of oxygen. Warning, you're running out of, like, you can actually let people know they're in trouble by vignetting, adding film grain. And can you guys see that? I don't know. I really don't know if that can come through on the thing, but like each of the pixels is just kind of flickering a little bit like this. And when you go out of the area, there's no flickering. You go in here, and these things are like shh. You can have different post-processing volumes in the same area, and you have to choose which one takes place first. That's basically it. So, how do we have the player behave a little bit better in a? So if I jump in here, you can see we got a vignette going on. Maybe a little bit of bloom. I don't know if I turn that off or not. You got the film grain on that, and then we can leave. Okay, so this whole thing though is kind of garbage. And so what you want to do is that's actually controlled by your third person character. So if we go over to the third person blueprints and go to BP third person, there's something called the character movement component. We've talked about this before when we were doing the sprinting system. So character movement general settings, character movement walking, character movement jumping falling, character movement networking, swimming. Here we go. Okay, so this is these are the settings for swimming. And so Swimming is automatically enabled when you enter a water volume. It just automatically turns on the swimming mode for you, and the default swim settings are kind of bad, as you saw. And so if we set a buoyancy of 0, compile and save. Over here, then we just walk along the bottom, right? You see that? So it's just, we're not floating at all, right? Moving slower because the water's kind of sluggish, but like, you know, no buoyancy, all right? And then if you set the buoyancy up a lot, like, I don't know, 10, compile and save. Then, wonk, 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 wonk. You go down, and then the water flings you back up at 10 times the you know, force of gravity, essentially. And if you turn that up all the way, in fact, let me make a little staircase or something. That could be kind of fun. Let's see here. Place actors. Make a little staircase. Showing up. Okay. Make a little diving platform here. Stretch it out a little bit. Okay. Move a little bit closer so I don't have to run all the way. And we can add a material to it too, but I'm not going to worry about it. Okay, so we're making a little diving platform here, and maybe I'll add a box to it. It should be doing snapping to the nearest object. Okay, that's good. All right. So I made a little diving board kind of thing, and I can run over here, jump off, and bloop. So what if I come back in there and save that, and click on the character movement and set the buoyancy to like 2,000. If I can get enough downwards velocity to do this. Boing. What do you guys think? So I did this once accidentally. I was making a video game, and I was trying to set the buoyancy on the character to be 0. So basically, even in an underwater area, it was slightly pulling you down. So I was trying to add like an upwards component to the character's velocity so that it would balance out and the person could tread water without rising or falling. And the value that I punched in was a order of magnitude too high. So I made it so that when you touched water, you would be flung up out of the water like this. Not quite this high, but like, you know, high. And I just started giggling like a child. Like when I saw that, I was just like, all right, that's the funniest thing ever. You know, because like you could just traverse through the map by just like bouncing on the surface of the water like a giant freaking bunny rabbit, you know. And I'm like, all right, this is the coolest thing ever. And so I actually left it in the game as an option. So servers could actually turn on that. Oh, did I? I'm not going to hit it. No. Air control. No. I was hoping to hit it again. Dang it. Loss. Okay. And so it's actually a server setting. And it actually made the game really interesting because all of a sudden, like water had a completely different purpose in the map. Normally, water is there to like hide you from sight, and you can like sneak in underwater. And now you can just like go like this and just like use it like a giant trampoline. You know what I mean? So you're just like, oh, let me get up to that platform over there, Wong, you know, and you just like bounce over to it. You know what I mean? And so it was actually a very popular server setting, and like a lot of people would just like leave it on because it's funny as hell. You know, a lot of maps would get broken. Like if you had to, like if the only way in was like through an underwater entrance, like it would just break the map. So you'd have to turn it off for that map. But in general, like it was surprisingly like just how many maps were just really made really interesting by having Jello water like that. So that's something I'm kind of proud of. Okay, so let's come back over here and set buoyancy to like 1.2 maybe. Let's try that one. Try to come up with something a little more interesting. Well, I mean, Jello water is interesting. More realistic maybe. So we're under here. And so you can see we're kind of like, yeah, kind of doing the water thing, you know. Now we don't, and we're just kind of gliding still, which is kind of awkward. Okay, here, buoyancy, acceleration, swimming. Let's try that. I don't remember what the number is in there. Seem to be doing too much. I don't remember what value that is. Deceleration when swimming and not applying acceleration. Let's try 200. It is kind of weird when you're just like kind of like moonwalking around like that. Nope, that didn't do it. Oh, there it came to a stop. Okay. Yeah. It's probably better than what we had before. All right. Buoyancy, maximum speed. Maybe that's fine. Max out of water step height. This is actually kind of important. Sometimes you'll get stuck in water, especially when the edges are like kind of steep. And so you sometimes need to increase your out of water step height so you can actually get out of a pool. Because a lot of times like you'll fall into a pool and like your head's like here, like hitting the edge of the pool, and you don't have a mantling system or anything to like climb out. And then you're just like, oh, I'm just stuck, you know? And so you can add in a larger step height so your character will get out of the pool if they need to. And then this will also fling them up so that when you hit the edge, it'll kind of dolphin you, right? So you kind of like pop up out like that. And we try turning that up to 2000. Thank you very much. You see that, like when you hit the edge, like it'll kind of kick you up out of the water. We probably should make it so you can jump underwater. Like I feel like that should be something we should have. Okay, and so fly speed. Yeah, that could be actually kind of fun too. Do you guys want to learn how to fly? Okay. Well, obviously. Was that the guy that said like hide your women, hide your kids? Okay. Hit scan weapon. All right. So I think we're fine here. I kind of want to have like the ability to jump underwater, and the reason why jump doesn't work is because I don't think it works when you're swimming. Wait, capabilities can jump. Yeah. Let me worry about that later. So, see if I'm remembering how to do this. Set max fly speed. Movement mode, that's the one. Okay. So what we want to do is set the movement mode to flying. Not flying, flying. Okay. So that's basically all it takes if you want to fly. You don't have to do drugs or anything like that. You can just hit a button and make yourself fly. So we're going to have to make a new input binding. So we go to Edit, Project Settings, and go to Input here. And we'll make a new action mapping. I don't know. F for fly. Does that work for you guys? What do you think? We call this one perfect. Okay. I believe I can fly. Okay. And I hit that and hit F. Easiest way of finding the key, and there we go. So that's saved. So I'm going to do a new event flying here. And so when they press the F key, they will begin flying. And when they release the F key, it will stop flying. Or I can toggle it. Let's try it this way first and see how it works out. Control D to duplicate. U and U. And movement mode will go back into walking. Okay. So when they hit F, as long as they hold down F, they're going to fly. And when they let go of F, they're going to walk again. Probably we should turn that into a toggle, but let's just see how this works. Okay, so F. I can't jump, right? Yeah. Okay, there we go. So I'm in midair, and then when I let go, jump F. And then let go. I can't jump though when I'm in flying mode. So I'm holding down fly mode right now, so you can see I can fly. But I can't jump when I'm in flying mode. I can't jump when I'm in swimming mode. So when I let go of F though, I'm back in walking mode, and then I can jump again. So I can sprint and hold down fly, and yeah, just kind of enjoy life. Let go of F and hold down F. Nope. You have like no friction, I guess, when you're flying. That's kind of funny. And let go. Okay, that's it. That's all it takes to learn how to fly. Glide mode, hover mode. Is there a way to make it so that something like if an item shows up if you're a certain movement type? Like, let's say when you toggle fly, all of a sudden holding a balloon. Yeah, you can do that. Basically, you can just get the movement mode. Like, anytime you want to do something, you can just be like, you can drag the character movement out, and then go from there and say get movement mode. Get movement mode. And then that'll tell you if they're flying or not. And then you can say if that equals enum, if it equals flying. So if their movement mode equals flying, then do something. Okay. If you want to, like, it would be kind of cool, like if like you hit flying, like you hold down flying, and then like objects appear in the world, like rings in the sky or something like that. You have to like pilot through. And then when you let go, they vanish. That could be kind of fun. You guys want to see how to do that? Do like some like pilot wings or whatever that video game is. To give me more ideas. Well, I mean, this one at least was like pretty easy, right? Just kind of, just turn on flying mode. So yeah, let's think about that. So first of all, click on the character movement, and let's just see if there's anything we need to set over here on the walking, jumping, falling, networking, swimming, flying. Okay, max fly speed 600. Okay. I guess we could probably up that maybe a little bit because it feels like I'm not quite flying fast enough. Okay. So let's say that when we hit F to fly, do you guys want this to be a toggle, or do you like it how you can like hold it down? Because like it's kind of cool, right? Like you jump off a thing, you hit F, you like skid through the air, and then let go, like hover boots. I did that when I spun a garden in the third project. Yeah, I can't believe you've done so many projects. That's amazing, honestly. Yeah, you just toggle the visibility on things, right? So what do you guys think? Do you like holding it down and you can kind of like skate through the air, or do you like it where you hit it and then you fly and you hit it again and you drop? Toggle? Okay. So we're going to toggle it, then we're going to need a Boolean, like we have our sprinting guy here. And this one's going to be called is flying or something like that. And public. I don't think we need it to be public right now. Okay. H forever. Yeah, okay. Let's do that real fast. So we'll do H for hover and F for fly. Okay. So we'll switch flying to hover and switch U to be H, switch U to be H, and then we will add a new action mapping for flying. And set U to be F, and save everything. Put U, and we will do event hover. So I need to edit the comment. I can believe I can hover. Okay, so that we don't need anymore. Okay. So this code will implement hover mode. So as long as you hold down H, you're going to skid through the air. And as long as you hit F, well, we haven't done that yet. So jump and H, jump and H. And then let go. Okay. Sweet. So that works. And now, there go. Okay. Now we're going to do the same thing, but toggleable. Okay. So by default, is flying is false. So cool. All right. So now we're going to do event fly if you guys want to see how to toggle it. So if they press it, we toggle. We don't do anything in release. Okay. So flying, we get the value. Yeah, we'll get the value and set it to not Boolean. Not, thank you. U to line them up, and then we will set is flying to that. Click, 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 there. And so now every time we hit F, it's going to toggle our flying state. There's probably going to be some sort of anti-synergy between flying and hovering mode. Whatever, I don't care. Probably, yeah, whatever. If I was writing a commercial game, I would have some sort of way of preventing both of these from happening at the same time, because they're going to like step on each other's toes, but I don't care. So if is flying is set to be true, then this will do a branch. Here. Okay, and then we're basically going to do the same thing. So drag out the character movement, and so if we are now flying, we will set movement mode to be flying. And if is flying is false, we are going to set movement. Let's duplicate this. Control D to duplicate. Hook you up to there. Connect you to there. Movement mode is now walking, and there you go. So that should be good. All right. So we jump and hold down hover. We let go of hover, and we're good. Jump and hit F, and we are now flying. I'm not touching the keyboard now. If I hit H and release, it'll drop it. Like I said, there's some weird anti-synergy between flying mode and hover mode, but there you go. So I'm flying, I hit F, and flying mode is off. Okay. I could probably add a heads up display to say, you know, flying mode is on or something. I could sprint, and there you go. Hit F, and it drops. All right. So that's flying. That's cool, right? I think it's cool. And so like we wanted to like do something like show a bunch of things in the world, and that'll be the last thing I show for today. Okay, so save everything. There we go. All right. So we will make a new blueprint. And do you guys know what I'm talking about when I say Pilot Wings? It's like one of Nintendo's least known like franchises. Samantha, do you know about it? It's like they keep like bringing back like references to Pilot Wings and things like that, even though they don't really ever do anything with it. So it's a game where like you're flying around and you like fly through like targets and things like that. Yeah, it's strange. It's like for all of like Nintendo like will have references to it in like different games, but like they don't really do much with it. Wow, look at you can count those triangles. Look at that. That's the N64 right there. There's a triangle, there's a triangle, there's a triangle. Okay. So we'll do something like that. So we're gonna make like a ring or something. A ring of fire. Okay. Let's do this. Cylinder. Put this up in the sky. Cylinder here. And the other thing we'll do is another cylinder. Actually, we'll just duplicate this one. Did that work? I don't know if it worked. Did it work? It worked. Okay. So we've got two different cylinders here. And this cylinder, I'm actually going to scale downwards in 2 of the dimensions. And then I'm going to move it over here. And I'm going to set it to be a subtractive layer. And there we go. Ah, cool. What do you guys think? You like that? So I made a cylinder, and then I duplicated the cylinder and shrunk it just on the 2 of the dimensions. The length is still the same, so I just shrunk it down a little bit, and then I set it to be a subtractive brush. This is called constructive solid geometry. You can only do it with the geometry tab things. You can't do it with normal meshes. But it's really useful for making like tunnels and things like that really quickly. And if you wanted to, you could adjust the, if you don't want it looking quite so angular and like 1996 looking, you could like adjust the number of sides and things like that on it. But this is fine, I guess. Surface material, let's see, gold maybe. Select all of them. Let's see here. Let's select all of the. Where is the option for that? Geometry. Select all adjacent surfaces. Okay. Select 2 materials and. All of you are going to be set to be gold. I like gold. There we go. All right. And then click on you and select all adjacent surfaces and set you to be gold as well. Or maybe we can do something cool on the inside, like chrome. There you go. So we've got like this cool cool little gold on the outside, silver on the inside tunnel. And so what we're going to want is we're going to create like a challenge where like you have to like jump off a cliff and then like fly through the rings essentially, you know. And like I said, you can increase the number of sides so it doesn't look quite so, you know, you can count the sides, but I kind of like this. I kind of dig it. Looks fine to me. I don't know. Okay, so we got this thing here, and I guess we're good on the modeling. Steampunk vibes, yeah. It's I kind of like it. I'm actually happy with this, especially with the ray tracing, kind of making it look, you know, kind of realistic a little bit. So what I'm going to do is I'm going to select this thing, and I am going to turn you into a blueprint. You're going to be called a ring, target ring, maybe. I don't know if this will work. Target ring, BPs. Let's see if this works. I actually don't know if you can do this. Come to think of it. Drag it out. Yeah, it's not getting the geometry. Yeah, I might have. Let's see. I have to convert to a. Let's see. You select the entire brush. Okay. And I want to export you as a static mesh. I might have been too clever for myself. I'm gonna need to look up how to do that. I don't remember off the top of my head. I don't do CSG stuff that often. But anyhow, so the notion would be you basically say here, you say get all actors of class, and you're gonna like Brittany or Megan, you did that with can you create a static mesh BP and build a ring inside of it? Yeah, it's a good question. I seem to recall there being a way that you could export a brush as a static mesh. I don't. It's been years since I've looked at it though, so I don't know off the top of my head. Yeah, let's just see if we can do that. I don't know if you can. Let's see. Add. These are all static meshes. Yeah, I don't know if actually a blueprint can have CHE inside of it. I think it might have to be a static mesh. Like I said, it's been a while. I'm going to need to look that up for you guys for next time because we're basically out of time. But the general idea is that like when you start flying, you're going to select everybody of type. Well, I was going to have it be the floating rings, but let's say I don't know, zombie or something like that. So this is going to return an array, and so this is going to be every actor of type zombie in the world. And so basically, when we fly, maybe all of these guys become invisible. So we will do a for each loop. So for each zombie in the world, while we're flying, it's cool, you can fly, but all the zombies turn invisible. I'm basically doing the opposite of what I'd been intending to do, which was to have all of the rings be invisible, and when you hit flying, they appear. Instead, I'm going to make it so that when you fly, all the zombies vanish. They're still there, you just can't see them. So for each zombie in the world, we are going to set visible set actor hidden in game. There you go. Yeah, do this. So we are going to set each zombie to be new hidden, whether or not to hide it is true. And then when we finish flying, we're going to do the same, but in reverse. And we're going to set it hidden to be false. So that should give you an idea of what I was going for. Let's see. So we got zombies, and then I fly, and all the zombies are vanished. I stop flying, and they reappear. So it's a downside of flying. Okay. Where are the zombies? Oh, there he is. And I died. So,
Bruh.
oh, nope. Did I make it? There we go. Okay. And I died again. Dang it. This game's hard. Okay, so can these guys hit me? Oh, maybe they're not. Oh, yeah, they hit me. Okay.
Bruh.
Yep, I can probably get up to that zombie up there now, right? He's invisible. Come over here, dude. No, can't get me now. I'm right here. Come get me. I'm right here. Right here. Do you see me? There we go. Yeah, so he's still there. You just can't see him. So, definite downside to flying. Okay, so that's basically it for today. So we went over a lot of important stuff today, actually. So the linear algebra stuff, I know maybe it's sort of boring for you guys, but like that's the heart and soul of video games, whether you want it to be or not. But it just when you develop that kind of fluency and proficiency with the linear algebra stuff, you can do a lot of things that people who haven't had the math just can't. And for whatever reason, a lot of game dev programs just don't teach any of the math, and it just baffles me that, like, all right, how do you make a game without that? I don't know. Like, you know, the zombie stuff, right? The AI controller, actually, zombie brain. So every tick, it's doing a displacement vector. It's getting a range. It's checking to see if they're within range. It's doing a dot product right here, seeing if the you know what I mean? Like, this is all like just basic math for doing basic stuff in games. You got a line trace, and so yeah, the math isn't fun, but you know it's really useful, and to me it actually makes linear algebra a lot more fun when you know there's actually real game world uses of it. And then we worked on the post processing volumes. That's going to be your homework due on Tuesday. You're going to have to build an underwater part of your level. Probably a little bit bigger than what I have here. Mine's about 10 meters by 10 meters. I want you to build like an actual like little underwater level. Have physics volume, post-process volume. You don't have to do flying, although it's kind of fun. I don't know. Add it if you want. And yeah, and then the last thing I showed really briefly is that you can get everybody in a world by doing get all actors of class. In this case, I'm getting all the zombies, and then you can do stuff to them. For example, I could have all of them take 10 damage every time I fly. They all take damage or something like that. Like you can do anything with it. In this case, what I'm doing is I'm saying for each zombie in the world, set it to be hidden. When I stop flying, for each zombie in the world, set them to be hidden. Not hidden. Hidden to be false. Okay. Any questions about that? Are you guys excited to make an underwater level? Every game has to have an underwater level, right? Mario Brothers, you have to go underwater every once in a while. Yeah, it's fun. It's neat. Add some kelp, add some seaweed, make it nice. It's fun. Do you still want me to present today? No, just do it on Tuesday with everyone else. And then the board game club is tomorrow. So there's extra credit. If you guys show up to the board game club and do a game review of the board game you play there. Mario 64 Secret Water flashbacks. You have to work. I'm sorry. Maybe next time. It's every last Friday of the month or something like that. Yeah, board games, like I said, they're a great way of studying game design. So, but I'm pretty sure you know them pretty well already, Megan. If you own 300 of them. So. Do the board game meet on any other day besides Friday? No, it's always the last Friday of the month. So, if that doesn't work for you guys, maybe I don't know. I'm always down to play Dune. So if you guys want to have like an IS-50 like extra credit get together in like the pit or something like that on campus and just play a game of Dune, let me know, and we can do that for extra credit if you want. So, custom country, yeah. I yeah. It's a thing. It's a thing in our family too. Like trying to find storage space for all of them for sure. The IKEA calyx is oftentimes considered like the. I've been literally looking at these like these last couple of weeks. Like, I've moved some stuff out of the way so I can like put a calyx installation and get my board games all organized and stuff. Okay. It's not a book problem. It's a good habit. Okay, yeah. So let me know if you guys want to do Dune sometime. Like I said, I'm always down. And that's it. So have fun building your underwater Little Mermaid experience, and I'll see you guys on Tuesday. All right. Peace out.